All right, let's get started. Hi, everyone. Thank you for joining us today. My name's Catherine, and my teammates are Leah, Rick, and Adam. We've spent the past few months building Tapestry as a fully remote team spread out over the United States. So, what is Tapestry? We are an open source data pipeline orchestration framework for user entity data. With Tapestry, your user data pipeline will be automatically deployed and ready to ingest data from all your user data sources, store and transform that data in a data warehouse, and sync that data back to your data tools for immediate use. But why would a business need a pipeline to move user data between different tools? And if you did need a data pipeline, why would you need an orchestration framework? And what even is user data? Perhaps the best way to discuss these topics is by diving into a simple use case. Let's start with a hypothetical. Rainshield is a company in the umbrella space with a thriving e-commerce store that is quickly gaining traction amongst a larger user base. This has attracted the interest of investors, and they've raised funding that has allowed them to expand. The small team that started Rainshield is no longer able to wear all hats, and they are beginning to staff larger departments, such as sales, marketing, and customer support, to manage the influx of new business they're experiencing. As the business evolves, Rainshield begins to utilize various SaaS tools in order to engage with their user base in new ways and to meet the daily operational needs of different departments. For example, they began to use Stripe to handle all of their online transactions. The company's sales team has started using Salesforce to organize and track their leads. And the Rainshield customer support team is now incorporating Zendesk to help with managing all of the support tickets that are now being generated. The marketing team is even planning on hosting a Zoom webinar on a design your own umbrella product that they're about to unveil soon. Prior to this growth, user data was largely managed in the production database. However, these teams are not only requiring different views of this data to accomplish their goals, but are also creating new sources of user data as they interact with customers through a variety of platforms and tools. While these third-party SaaS tools cater to the needs of each department well, user data is beginning to proliferate the organization in terms of both the data produced and collected. Data is becoming scattered across the different tools each team is using. And these tools were not designed with integration in mind. It's becoming more challenging to have a unified understanding of a single user and how they're interacting with Rainshield and its product. Each tool has access to only a portion of the customer's information, but not the whole picture. And these SaaS tools that have increased productivity have now become data silos. Data goes in, but it doesn't come out. The industry agrees that this is a big challenge. Colin Zima, the Chief Analytics Officer at Looker, says, "The big fear that I always have is that people are using more and more of these SaaS tools. The average company has a ton of SaaS tools and all of them have data locked in. So Salesforce has some of your sales data, but Slack has chat data, and you've got all these systems that are holding data sets." Take, for example, Susy, a Rainshield customer. According to her profile in Salesforce, Susy has purchased 6 umbrellas for her friends and family. However, Zendesk indicated that she called 2 times complaining about the color of some of her umbrellas. Susy is excited about picking her own umbrella color and is signed up to attend the Zoom webinar unveiling the new Design Your Own product. When this data about Susy lives in different tools, it becomes difficult to access a composite picture of Susy. Now, We've only mentioned a few different tools that Rainshield uses that store user entity data. We've also only talked about one customer, Susy. But it's easy to imagine that Rainshield could use many more tools that capture different pieces of user data, and that they might have thousands of different customers buying their umbrellas. And what if there were more users just like Susy, who have bought at least a few umbrellas, called customer support about their umbrella color, and have signed up for the webinar? When all this data can be collected in one place, Rainshield can begin to see patterns among their users and act on these insights. And when you think about how important it is to have a complete picture of your users, you realize just how critical it is for a company to integrate user data from every source in order to operate effectively. So, how can Rainshield put all these pieces of the pie together for all of their customers? And even if we are able to gather this user data for analysis in one place, how are we going to use these insights to impact day-to-day operations? Let's take a look back at our company, Rainshield. Let's say Rainshield would like to use what they know about Susy and other customers that match her profile in an attempt to increase sales. They believe that this group of users will be especially interested in the new umbrella colors that Rainshield just rolled out. And they would like to prompt these customers with a custom chat message via intercom the next time they log on. But before this desired action can take place, Rainshield still needs to provide intercom with this specific list of customers. In other words, making insights actionable still requires work. Rainshield needs to map relevant user data to intercom in the particular format that intercom requires. This process could be thought of as data syncing. Is there a way Rainshield can automate the syncing of data? So let's take a step back and recap the obstacles that Rainshield and companies like it are facing. Important user data is being trapped in silos as the quantity of Rainshield's SaaS tools increases. They would like to aggregate data from these disparate third-party sources into one location for better analysis. Additionally, they would like to sync relevant data to other third-party destinations to drive operations based on their findings. But what are the challenges of this type of data integration? User data stored in SaaS applications is similar in structure to the data we see in traditional relational databases. However, unlike relational databases, data in SaaS applications cannot be accessed with a simple query. Instead, this data must be retrieved via unique REST APIs, making it difficult to determine how to communicate with each tool. Furthermore, factors such as limited documentation, rate limits on API requests, managing potential network errors, and ever-changing API schemas can make transporting large amounts of data a challenging and slow process. So, how can Rainshield navigate these challenges and eliminate these data silos? They have four main options for arriving at the desired outcome. One, they could manually move files between tools. Two, they could use pre-built connectors. Three, they could create their own custom connectors. Or four, they could build a complete data pipeline. We'll discuss each of these in turn. Let's talk about the first option, manually moving files between tools. Let's say that Rainshield wanted to make sure that Salesforce had all of the contacts from the Zoom webinar, revealing the new Design Your Own umbrella. They could simply export the list of webinar attendees from Zoom to a CSV file, and then import that file into Salesforce. But this might result in duplicate data and could become tedious if you have to do this task often. Another possibility would be to use a company that creates these connectors for you, like Zapier. Rainshield can give them some information about their Zoom and Salesforce accounts, and they set up the flow of data between them for you using pre-built connectors. This, however, would not allow much flexibility regarding which parts of the data would be shared between the two apps. You might still end up with duplicate data, and you may not find all the apps you need to integrate together on their menu. Another type of pre-built connection sometimes exists in certain tools settings. For example, Zoom has a way to integrate directly with Salesforce by simply configuring your settings to export your data. This isn't always the case though, and more than likely, Rainshield will not find every tool it uses in every other tool's configuration settings to sync up. The third course of action is that Rainshield could designate 1 or 2 software engineers to begin building custom connections to pipe data directly into all of the tools that they use. The benefit of this option is that you can flexibly choose what data to extract and sync. However, not only would these engineers have to research these tools' APIs to extract data, but also to sync as well. This might not be too bad if the number of tools the company used was very small. For example, if Rainshield only needed to connect Zoom and Salesforce with MailChimp, then they might only have to write 6 connectors to ensure they all shared the same data. You can imagine each of these lines representing a pair of connectors for each individual tool. However, if your company already uses several tools or plans on growing in the future, this can quickly get out of hand. And that's to say nothing of the fact that these connectors would also have to be maintained. If one API changed, it would need to be altered for all the other tools trying to use it. And the reality is that even small companies use anywhere between 10 to 50 tools. That would require a lot of valuable engineering time that could be better spent on core product development. Perhaps the best and most complete solution is our last option, implementing an end-to-end user data pipeline with a cloud data warehouse at the center. From an engineering perspective, this approach allows access to data ingestion and syncing tools that remove the headache of working with third-party APIs, while also providing you with the flexibility that custom connectors offer, i.e., you choose exactly what data to send. Placing a cloud warehouse at the center of your pipeline also provides several other benefits. Cloud data warehouses allow for the storage of large amounts of data with very little infrastructure management and instant scalability. Warehouses may also serve as a single source of truth if 2 departments ever had conflicting data. Additionally, data modeling and analytics tools can be built on top of the warehouse and can aid in making important business intelligence decisions. Lastly, the warehouse offers the ability to combine and filter data from multiple sources in order to sync with another destination. This warehouse-centric pipeline helps aggregate all of your data into one accessible place so you can create unified models and sync them to the tools your teams need. Businesses can rely on a single pipeline for both analytics and operations to better understand and leverage user data. Here's what the CEO of RudderStack thinks of this approach. You should not have point-to-point integrations. You should be bringing everything to the warehouse and then pushing it out to the destinations. That is the way it should be. I'll hand it over to Leah now to discuss some existing solutions for creating a user data pipeline.
Thank you, Catherine. When deploying this type of user data pipeline, the 2 primary options are to use a proprietary hosted solution, such as the one offered by the company RudderStack, or to use open source tools to configure your own pipeline. The DIY option does allow for the inclusion of fully open source tools, while RudderStack only offers open source event streaming. One other point in favor of the self-hosted solution is that it grants you full ownership over your pipeline infrastructure, which means you can customize it any way you like. On the other hand, RudderStack requires you to use their infrastructure, leaving you with little control. One benefit of RudderStack is that it has lots of out-of-the-box features, whereas a self-hosted solution has none. One other advantage that RudderStack has over a do-it-yourself approach is a big one. RudderStack abstracts away infrastructure provisioning and management, making it extremely easy to deploy a user data pipeline quickly. In contrast, building your own pipeline requires an extraordinary amount of time and effort to set up, provision, and configure. You need to make many different decisions about which tools to use for data ingestion and syncing, and which warehouse to select. And that's not even mentioning all that goes into provisioning and maintaining pipeline infrastructure. To say the least, this is an extremely complex process. This is why we built Tapestry. We weave together all of the necessary resources to create an end-to-end user data pipeline, automate the setup and configuration, and let you spend your valuable time doing something more important. Tapestry is for engineers who want full control over their data infrastructure, but without having to provision that infrastructure for themselves. Tapestry is a completely open source framework that automates the entire pipeline deployment process. We do not, however, have very many out-of-the-box features. So if you are thinking about rolling your own self-hosted solution, but wanted to simplify the deployment process, we might be able to help. Tapestry automates many steps and creates a number of resources for each phase of the pipeline. As you can see, deploying your own user data pipeline would require at least 71 steps and the provisioning of 49 resources between both AWS and the data warehouse. Let's see Tapestry in action by walking through a demo. Getting started with Tapestry is pretty simple. If you're the engineer, you would first need Node and npm also installed, as Tapestry is a Node package. Additionally, since Tapestry is specifically configured to provision a number of AWS resources, an AWS account, along with the AWS CLI installed on your machine, are both required. Finally, users will also need to have a Docker account and have it installed on their machines. After these preliminary steps, all you need to do is run npm install Tapestry pipeline with a global flag, and a host of commands will be provided to you. As a new user, the first Tapestry command that you would run is Tapestry init. With init, you give your project a name, and Tapestry will provision a project folder along with an AWS CloudFormation template, which allows you to provision and configure AWS resources with code. This template in particular is used to provision resources for the data ingestion phase of the pipeline. What Tapestry does provide for the syncing phase of your pipeline is dependent upon which command you run next. You have a choice between our deploy and kickstart commands. Once you make your selection, Tapestry then provides all of the necessary configuration files for the data syncing phase. Both commands automate the deployment of a fully operational pipeline, but Kickstart includes two pre-configured sources, Zoom and Salesforce, along with one destination, MailChimp. These pre-configured third-party tools set up your pipeline to have immediate end-to-end data flow, beginning with data ingestion and ending with data syncing into these tools. To better show the full flow of data through our pipeline, we'll demonstrate our Kickstart command. Prior to execution, you will have to own or create accounts for Zoom, Salesforce, and MailChimp. Kickstart then begins by prompting you with a short series of questions about the previously mentioned accounts, as well as Snowflake, Tapestry's data warehouse of choice. After your information has been collected, Kickstart continues by creating the necessary databases and tables within your data warehouse to be utilized by both your ingestion and syncing tools. Let's take a peek under the hood at the actual infrastructure that this command is provisioning. Tapestry uses the CloudFormation template supplied during the init command to create a CloudFormation stack, provisioning AWS resources specifically related to your ingestion tool, such as an S3 staging bucket, an EC2 instance for the tool to run on, and an application load balancer to route traffic to our EC2 instance. The ingestion tool is then configured to extract certain data from your Zoom and Salesforce accounts and send it over to your warehouse. You will then be asked to carry out a few steps so the data is transformed in your warehouse using a data model that Tapestry gives you. Essentially, the data will be aggregated from both sources into one table, filtered for duplicates, and appropriately formatted to be synced to MailChimp. To complete the pipeline, Kickstart creates another CloudFormation stack, this time spinning up various AWS resources for your syncing tool, such as an Elastic Container Services cluster, which is used to properly run your syncing tool's application, and another application load balancer to route network traffic to your cluster. If you are deploying a new pipeline, Tapestry automatically launches your very own local Tapestry dashboard. This dashboard contains documentation for how to use Tapestry, along with various pages for each section of your pipeline. Each page displays metrics that give you better insight into the health of each component. They also include links to the UIs of all the tools being used at each stage of the pipeline. Now, let's actually see data flow through the entire pipeline with an example. Let's use a pipeline we just set up with Kickstart to grab our Zoom webinar registrants, also along with our Salesforce contacts, and then sync them into our email marketing tool, MailChimp. Our goal in this example is to extract data from both Zoom and Salesforce and push it to our data warehouse, Snowflake. From there, we want to combine the webinar registrants from Zoom and our Salesforce contacts into one single list and filter out any duplicates along the way. Finally, we want to send this new complete list over to MailChimp. As you can see from this table, we have several different people who have registered for a Zoom webinar. Of particular note are Diana Prince, Barry Allen, and Betty Rubble. As indicated by the green box, Betty Rubble is a unique contact only found in Zoom, while the red boxes around Diana and Barry indicate contacts that are found in both Zoom and Salesforce. Our goal is to get all three of these entries over to MailChimp, with only one entry each for Diana and Barry. Now, in Salesforce, we have a different list of customers. In the yellow box, there's a contact who is unique to Salesforce, Jack Rogers. And you'll remember Diana and Bartholomew, also known as Barry, from a previous Zoom list. Even though Barry is going by a different first name in Salesforce, his name is the same across both sources, or his email is the same across both sources, allowing us to uniquely identify him. This means that when we combine the two lists, we can use the email address field as a unique key to eliminate record duplication. Once the data from both Zoom and Salesforce have made it into our Snowflake warehouse, we can transform the data by combining both lists and removing duplicate entries. You can see the two tables highlighted in purple. The Tapestry webinar registrants table has all of our Zoom data, and the Tapestry contact table has all of our Salesforce data. The email model table that is highlighted in blue is the newly transformed table that we will sync to our MailChimp account. Finally, here in MailChimp, we see that we've successfully synced all of our Zoom webinar registrants and Salesforce contacts and made sure that there is only one entry for Barry and Diana. You can also see that our unique users, Betty and Jack, made it over as well. Now that we know how Tapestry works, let's take it over to my teammate Rick to explain how we built it.
Thanks, Leah. Before diving into the specifics of Tapestry's architecture, let's quickly revisit the three phases of our pipeline: ingestion, storage and transformation, and syncing. The ingestion phase is where data is extracted from various sources and moves into a data warehouse. Once in the warehouse, this raw data is then stored and is available to manipulate or transform in any way needed. Often, transformation is needed at this step so that the data can match the schema of the final destination. Finally, the last phase is syncing this data into external tools that can then perform designated actions. In the upcoming sections, we will walk through each of these three phases in Tapestry's corresponding architecture. And as we do, we will consider these three questions. First, what is required of this phase? Next, what tools should be used for this phase and why? And finally, how will this part of the pipeline be deployed and automated? Let's start with data ingestion. An effective data extraction tool will contain and manage a library of API connectors specific to each source. This management of connectors abstracts away the maintenance required to grab data from ever-changing API endpoints. In addition, this tool should allow for scheduling data extraction and keeping track of global state so that only new data is pulled. Now, in order to make a decision regarding data ingestion, it's important to consider the path by which the data travels. In the past, storing data was an expensive endeavor. This made it more cost-effective to perform any sort of data transformations before loading the data into a database or warehouse to reduce the amount of data being stored. This approach is known as extract, transform, load, commonly referred to as ETL. However, with the advent of cloud data warehouses, costs of storing data have decreased dramatically. This makes it more feasible to store all of your user data as raw data and to perform any transformations at the warehouse level to fit a variety of analytic and operational needs. And since transformations aren't required first, data can be loaded extremely fast. This approach is known as extract, load, transform, or ELT. And since it was vital for our pipeline to have access to all of the raw data, we chose to go with an ELT solution. While many data ingestion tools are available, like Fivetran, Stitch, and Meltana, we ultimately went with Airbyte. We liked that it was open source, had standardized API connectors, a robust UI, and strong community support. Using Airbyte, we're able to extract raw data from many third-party tools through its library of managed API wrappers, covering the E and L of ELT. Both the Airbyte application itself, as well as each of its connectors, all run on their own individual Docker containers. So Airbyte provides the Docker image to deploy their application, and we configured our warehouse as a destination for Airbyte via a series of API calls. So essentially, the main application's container needs to be able to generate new containers as users set up more and more connections. Due to this necessity of a Docker container needing the ability to create other Docker containers, Airbyte recommends the use of an AWS EC2 instance as a virtual private server for hosting. And while we prefer to use a container orchestration service to horizontally scale the computing resources used by each container, an EC2 instance still allows for vertical scaling of the entire instance. Finally, placing a load balancer in front of Airbyte means traffic cannot reach the EC2 instance directly. Network traffic must first pass through the load balancer before it's routed to the Airbyte instance. This allows us to take advantage of additional security measures and keep the IP address of the actual instance hidden. This keeps the instance safe from any port scanning attacks and also takes advantage of AWS's built-in protection from DDoS attacks. While prototyping the ingestion part of our pipeline, we encountered an interesting challenge. Initially, all of our Zoom data was being extracted and loaded into our warehouse without any issues. But our Salesforce data was consistently timing out, eventually leading to a 504 server error. In AWS, we saw that our Airbyte EC2 instance was becoming an unhealthy target for our application load balancer every time we attempted a sync with Salesforce. So we dug a little further and found ourselves in the AWS monitoring dashboard searching for clues. There, we noticed that our CPU usage was through the roof. This led us to believe that the size of our EC2 instance may be the root of the problem. So we vertically scaled our instance and our error message disappeared. This also led to our decision to include a CPU usage section in Tapestry's dashboard to monitor our AWS resources, as shown before in our demo. Now, the next phase of our data pipeline is data storage and transformation. We'll address data storage first. We've already determined that at the center of our pipeline should sit a warehouse that is capable of handling large amounts of data from a variety of sources. Given our decision to host our tools on AWS services, a warehouse that could be seamlessly integrated with AWS is preferable. While there are many options for a data warehouse, we chose Snowflake. Snowflake can be built on most major cloud platforms, providing valuable flexibility. And Snowflake also separates storage needs from query processing, also known as compute. This allows companies to take advantage of cost savings, as well as enable us to scale those two responsibilities independently. And finally, Snowflake abstracts away the provisioning and maintenance of all the necessary resources for a cloud data warehouse. Initially, we attempted to load data directly into Snowflake from third-party tools, but we found the data transfer to be particularly slow. This led us to investigate using a staging area with Snowflake and how this impacts data loading. Without this staging area, Airbyte can only insert one row of data at a time into Snowflake, requiring numerous SQL insert commands to copy over an entire table. With the addition of a staging area, Airbyte can achieve efficient bulk data loading. To implement this staging area, we provisioned an Amazon S3 staging bucket between our Airbyte instance and our Snowflake data warehouse. One interesting challenge we encountered when working with Snowflake was how to run SQL commands for a new user once you have their credentials. We needed to run a sequence of 34 commands in order to set up the warehouse with the necessary databases, schema, roles, and permissions for the Tapestry pipeline to operate. We found that Snowflake provides a Node.js SDK, which would allow us to communicate with the Snowflake warehouse. Since the SDK only allows one SQL statement to be executed at a time, we needed to store each statement as an array element, and then iterate through each one individually. Now that we could execute each SQL statement individually, we ran into another problem because the SDK is callback-based and runs code asynchronously. To visualize this problem, we added a log statement with the array index. And you can see here how the statements are being executed out of order. The error logs indicated that Snowflake was attempting to create databases and tables before the permission and role statements had finished executing. One option for solving this might be to nest each callback so that the statements are executed in the correct order. However, this would result in unreadable code that would be difficult to manage. Instead, we opted to use the Snowflake Promise library. This library is a wrapper for the Snowflake SDK that provides a promise-based API. This made it possible to use async await to handle multiple promises in a synchronous fashion. Now, as you can see, the logs indicate the statements executed in the right order. Now let's talk about the other half of this phase, data transformation. A data transformation tool should be flexible so you can transform data to meet a variety of analytical and operational needs. Ideally, we would like a SQL-based data transformation tool that could be utilized by non-developers to create data models based on the warehouse and put that data into action more quickly. Finally, we would like a tool that maintains a history of our data transformations. Documentation about existing data models and how these models relate to each other can provide better context for how data has been manipulated over time. When considering these requirements for a transformation tool, one option stood out because it encompassed all features we wanted and was free and open source. And that tool was DBT, or Data Build Tool. As previously seen in our demo, DBT can be used to aggregate data and handle duplicate entries. Other transformations you might want to perform include changing column names and copying only the particular fields you need from one table into a new table. Because DBT has its own cloud version, Tapestry doesn't need to provision any resources for it. So we opted to go with the cloud version of DBT because of its ease of use and simple to understand UI. And now I'll hand it off to my teammate Adam to discuss the last phase of our pipeline.
Thanks, Rick. The last phase of our pipeline is data syncing. This is where we send data back into external tools that can then act on the data. Much like data ingestion, this requires a library of API connectors specific to each destination and the ability to schedule when you want to transfer your data. However, data syncing is more challenging than ingestion in that the data must conform to the destination's schema. This concept of syncing data back into your tools is relatively new and has recently been coined reverse ETL. If you recall, ETL and ELT are concerned with moving data from your tools into your warehouse. And reverse ETL moves data out of your warehouse and into your business's operational tools. This term, however, while becoming quite common, does not describe the process well, which is why we prefer the term data syncing. While proprietary tools exist in the data syncing space, like Census and HighTouch, we opted to find one that was open source. Grouparoo is just such a tool, does everything that we need, and they have a kangaroo logo to boot, making them an easy pick. Grouparoo recommends deploying their web application stack with an application layer and a data layer. Let's talk about the application layer first. This is where a worker server and web server will reside. When a request to sync data up with external sources comes in, it first hits a load balancer, which directs the request to the web server. From there, the web server can then offload the task to the worker if the task will take a long time to complete. When these slower jobs are run in the background, it improves the responsiveness of the web worker. The data layer houses the application database as well as the cache. Grouparoo recommends using Redis to serve as both the cache and also as the background job queue for the worker server. They also suggest using Postgres as the database where your user data will be stored. Let's take a look next at how this application architecture informed Tapestry's deployment of Grouparoo to the cloud. Given the distributed nature of this architecture, we thought it was appropriate to deploy each component as its own Docker container. This way, each container would have only one concern, and the decoupling of responsibilities would make it easier to horizontally scale in the future. Grouparoo provides a Docker image that can be used for deploying the web and worker service. Starting with their base image, we added the necessary configuration to integrate Snowflake as the data warehouse for Grouparoo to use as its primary data source. Of note, Grouparoo uses JavaScript or JSON files to store configuration details. And because of this, any configuration changes require the Group.ru Docker image to be rebuilt. So we chose to push the image that we provide to a repository on AWS's Elastic Container Registry, giving the user easy and private access for any future updates. Then we provided a generic Redis and Postgres Docker image to run the containers for the data layer. Now, because this is a multi-container deployment, Tapestry had to consider how best to handle container orchestration. Some popular options for container orchestration include Kubernetes, Docker Swarm, and Amazon Elastic Container Service, or ECS. Kubernetes and Docker Swarm are both highly configurable. However, the learning curve is steep. So we decided to use ECS to handle the container orchestration for Tapestry's Group.ru deployment because it manages and scales containers efficiently and automatically. This choice also gave us the ability to use the recently rolled out ECS and Docker Compose integration, which simplified this process even more. Docker Compose is a tool that allows developers to define and run multi-container applications via a YAML file. With this integration, we could seamlessly use this same Docker Compose file to deploy the Group.ru application and all its dependencies as an ECS cluster. AWS resources are created automatically based on the specifications in this file. This works because there are built-in mappings between the Docker containers defined in the file and the ECS tasks. ECS not only manages these containers, but the servers they live on as well. This occurs via AWS Fargate, a service that abstracts away server provisioning and handles it entirely on the user's behalf. We also provide a load balancer in front of the ECS cluster for all of the same reasons security-wise that we placed one in front of our Ingestion tool. Additionally, since we used a load balancer, we are also set up nicely to horizontally scale in the future if need be. Once Group.ru is deployed, you are ready to start pulling data from your warehouse and syncing it into other third-party tools like MailChimp. One particularly interesting challenge when deploying Group.ru was determining how to inject sensitive user inputs, like API keys or passwords, how to get them into the Docker container for Group.ru's web application. For Group.ru, we needed to reference these inputs in configuration files as environmental variables. We soon learned that you can pass environmental variables to a container by referencing a local.env file in a Docker Compose YAML file. And this solved part of the problem. The Docker container could now access any variables we provided in this file. However, because we were not receiving the user inputs until runtime, this .env file had to be dynamically generated after these inputs were received via the CLI, but before the container could run on ECS. Our solution for doing this was twofold. First, we stored the user inputs in the SSM parameter store on AWS. This ensured that this sensitive information was secure and encrypted, but also available for us to access from the AWS CLI as needed. Then we created a function to dynamically write the .env file in the user's project folder after we had all their inputs. Now that we have had an in-depth look at each piece, let's zoom back out to view the pipeline in its entirety. As outlined before, the amount of steps involved in the configuration and deployment of pipelines requires a tremendous amount of time and effort. And that's exactly why we wanted to build Tapestry, to alleviate the pains of pipeline setup for developers and save them valuable time in the long run. We also wanted the management and maintenance of the pipeline to be as easy as possible. So we provide a UI dashboard for monitoring the health of your pipeline and for observability. That being said, there are still a few features we would like to implement in the future. One thing we'd love to do is enable cross-platform support, such as deployment on Google Cloud Platform. We'd also like to deploy Airbyte with ECS so that our user has greater flexibility in terms of scaling. Airbyte has indicated that this compatibility will be available sometime in the future. Additionally, we would like to add more built-in templates to the kickstart command so that Tapestry can be used out of the box for more use cases. And lastly, we'd like to add more advanced metrics for pipeline monitoring, such as CloudWatch alarms that can send notifications when particular utilization thresholds are reached. And that's Tapestry. Thanks so much for coming out and listening today. At this time, we'd love to answer any questions that you might have, and we'll jump back now to our architecture in case any questions relate to it.
Okay, we have a first question from Kyle. Really awesome project, blown away. Good job, Tapestry. Question for everyone on the team. If we think of this project as having three sections, data ingestion, data transformation, and data syncing, is there a section that you found to be more challenging to build and configure than the others? I would love to hear your thoughts.
I can go ahead and take that one. Thanks, Kyle, for the compliment, first of all. Definitely the data syncing piece was the most challenging for a couple of reasons. On our data ingestion side, the tool that we used, Airbyte, in order to configure sources and destinations, you do that through either a UI or their API. So once you have that piece of the pipeline kind of up and running on your infrastructure, it's a little bit easier to interact with. Group.ru, on the other hand, has a code configuration. So kind of working through how to allow for our users to redeploy the infrastructure anytime they want to reconfigure their destinations was a bit more challenging. I would also say additionally that side was a little bit more challenging because Group.ru itself rolled out some updates while we were in the middle of implementation that were some breaking changes, and that was we had kind of a big weekend where we were trying to figure out what was going wrong there. So that was definitely a bit of a challenge, but the end result of that was kind of interesting that we ended up interacting with some of the developers there, and they rolled out new changes kind of based on some of our feedback on what was happening for us.
Okay, another question from Lena. Impressive work, Tapestry team. How was the experience of learning so many new technologies? I see you're using Airbyte, Docker, Snowflake, Group.ru on top of the AWS components.
I can take that one. Thanks so much for the compliment, Lena. Yeah, it was a really interesting experience. I think, honestly, I go back to the process that we always fall back on that we learn in core, which is PDAC, and just kind of breaking up a bigger problem into smaller little chunks. And just approaching it that way, I think it just makes learning all these new technologies more digestible and easier to kind of break down. And furthermore, once you start breaking them down into those different subcomponents, if you will, you're able to better kind of compare similar tools in the same space. So I think that also helps a lot. And yeah, I think it was super interesting getting to learn about all the different technologies, especially reverse ETL. Reverse ETL is an emerging technology over the last year or so. So that was really interesting to kind of get an inside look at this pretty new space and new technology. But yeah, it was a very educational experience, and Yeah, I hope that answered the question.
So what was your favorite or least favorite part of working on this? I guess that can be a question for everyone.
Sure. I can definitely answer first. So your favorite or least favorite part of working on this? I would say that my favorite part was after we had chosen our data ingestion and data syncing tools, figuring out how they worked, specifically with Grouperoo, our data syncing tool. It was a bit tricky to figure out how the mapping worked from tables in Snowflake to jump into the MailChimp. Basically, like when you're mapping data over, you kind of have to have the right table names. You have to clean the data. You might even need like certain columns that are required in MailChimp that are not required when you're describing the data. That was definitely challenging and interesting to figure out the code configuration for the data syncing component.
Yeah, I think my favorite part was probably the first time that we got data all the way through the pipeline. We're like, hey, it works. We did it. That felt pretty good. But yeah, to Lena's point earlier, it was a lot of different tools to learn. And on top of AWS, it was a pretty big learning curve, a big experience of figuring some new stuff out, but also fun on the other end of things. So yeah, I'd say my least favorite part, as Catherine alluded to, was the night that Grouperoo rolled out some changes that we were unaware of, and everything broke on the syncing side of things, and we couldn't figure out why for a while. And just debugging that was pretty painful. But yeah, it was an awesome project to get to work on.
Okay, we have a final question, and it's how you landed on this idea, Justin asks.
Thank you, Justin. I can take this one. So kind of overall, we understand that companies are adding more and more like data marketing tools, and even kind of seeing companies out like ourselves, we know that the aspect of user data is kind of becoming like a larger and larger aspect of how a company works. And after we kind of realized that was such a huge priority of companies, like to focus on their data analytics, then we kind of found ourselves looking into like how data was transferred from third-party tools, and then how companies were able to use that data. And that's kind of how we fell upon like data pipelines. And we also saw that data pipelines were generally like more focused on how could a company use like analytics tools and intelligence tools to kind of like grab insights from combining all the data to kind of make business decisions. Like how should they price their products? What new products should come out next? And we also kind of saw that there was almost like a missing piece, or like kind of a new part of the pipeline that came out, like that we refer to as data syncing or reverse ETL. A lot of open source solutions and even proprietary solutions stopped once they got data into the warehouse. So once we saw that grabbing the data from the warehouse back into those tools to actually be utilized in marketing campaigns and other tools like to be operationalized was new, we kind of found a hole in the market to have that as an open source solution.
So it looks like we don't have any more questions. So any final words?
Just say thanks everybody for coming out. Hope you enjoyed it. And if you have any other questions or want to chat, we're on Slack. Thanks.